Yeah, good afternoon. My name's Ellen Fay. I'm co-lead together with Pete Smith here, who's of the University of Aberdeen. We co-lead the Soil Health and Carbon Dynamics topic expert group for the Land Use for Net Zero Nature and People Hub. So for short, we call that the Soils tag. Um, can we go on to the welcome slide, Tilly? Thanks. So yeah, we've run a number of workshops in the soils tag up to now on different themes. And this workshop today is on the theme of soils and flooding. Flooding clearly poses an increased challenge across the UK. Last winter, we had months on end of rainfall, and we shouldn't let the following drought wipe that from our memory because this year, well, rains have come late, but actually, this workshop is of a particularly, it's particularly pertinent. We were just discussing before everybody joined what's going on in Monmouthshire, for example, from Storm Claudia. We know flooding is increasingly exacerbated by climate change. However, it's not always clear how land, and in particular soil management, is part of that story and what the mitigating role of soil might be. So, the purpose of today is to explore soil's role in flooding, whether from a causal perspective or in terms of resilience and water regulation. So we're hoping to learn how improved soil management can avoid or reduce, for example, surface runoff, enhance water retention, and minimize erosion, and what scientific insights decision makers might need to incorporate soil considerations and nature-based solution thinking into their strategizing around flooding. So we've got a lot to get through today, and I won't take up very much time in introductions, but just some quick housekeeping before I introduce our expert panel. This workshop is being recorded, and all outputs will be shared through the LUNS website. If you could just pop your name in the chat, that would be really helpful. We've got some really great presentations coming up right now, and there'll be a lot of conversation later on, which will be through a guided discussion. So if I can ask people to keep your questions, either keep them to store them up for the questions session, or if you pop them in the chat as we go through, we'll harvest those and make sure they come to light later on. So I think we'll go straight into, actually, Tilly, could you just pop the agenda slide up so we can go through what's going to happen so you know what's coming up. So we've got a really excellent lineup of speakers from different perspectives on this subject. Professor David Robinson, soil scientist at the UK Centre for Ecology and Hydrology, UKCEH. And Dave is going to talk about the context and the evidence for the role of natural flood management. We're going to hear from Dr. Richard Smith, who is technical specialist and practitioner really at the front line of this whole issue, working at the Environment Agency. And he's going to talk about, or he's going to give us actually some real clear illustrations of compaction and erosion causing localized flooding. John Boardman is Emeritus Professor from the University of Oxford, and he's going to talk about the experience, the same sort of experience, but in arable systems. And then Alejandro Dussaillant, and we're just discussing how to pronounce your surname. I hope I've got the double S and the double L right. Specialist in hydrology and nature-based solutions, also at UKCEH, is going to talk to us about nature-based solutions. As I said, following from the presentations, we'll have a guided discussion session led by my co-lead, Pete. So in the interest of time, I think we'll go straight on to your presentation, David, if you're ready. So Tilly, could we have David's slides? Thanks. And you could go into, that's fine. Yeah, perfect. Over to you, David.
That's great. Thanks, Tilly. So hi, good afternoon, everybody. I'm David Robinson at the UK Centre for Ecology and Hydrology, and I'm based at Bangor in North Wales. So I think the purpose of my talk essentially is to give a little bit of context. So if you want to go to the next slide. So if you didn't know it was wet in the UK following this weekend, then here's some more evidence that it's pretty wet in the UK. So in 2000, there was a Glassard report from the UN, and it ranked the UK as the second wettest country in terms of its soils, in terms of the area or the proportion in the world, following the Falkland Islands. So soils are inherently wet, and that's something to consider. We've spent hundreds of years trying to drain our soils, but that's something to hold in mind where they sit naturally. So if you want to go to the next slide. So this is some work from Simon Dadson and colleagues, which I thought is quite useful for setting some of the climate context. And the UK particularly has rich data when we look back in time, and this record from the 1770s looking at average rainfall amounts, annual average rainfall amounts for the UK. And so blue in the top right-hand graph is winter and red is summer. And one of the take-homes from this is that the actual amount of rainfall is not really changing, but it's certainly changing when it arrives and the amount in which it arrives and the structure of its arrival. So those are all aspects which affect how that water then is either infiltrates or runs off. And it's natural that we go through flood-rich periods and flood-poor periods. So we are just on the verge of coming out of a flood-rich period. So how it's altered over the last decade is still to be determined, but over the projections are showing that this sort of pattern is not going to change that much in terms of the actual amounts, but this more in the winter and less in the summer is certainly a direction of travel. Next slide. So another interesting piece of research that's come out recently came out from the Met Office, and that was saying that 50mm storms in October, November and December increased by 60% over the last century. And I think they're predicting that they're going to increase another 80% over the next sort of 60 to 80 years. So these very intense storms are certainly on the rise. And as we've seen over the weekend, I think down in Monmouthshire, they had something like 100mm in 24 hours. That's a lot of water. That's a huge amount of water to disperse and to get rid of. So next slide, please. Evidence. So evidence often is looked at in terms of scale, and we know that there's very strong evidence that soil management has an impact at the hill slope and the field scale, especially to do with muddy outwash and runoff. There is some evidence for a reduction in flood peaks and timing as induced by soil in small catchments up to the sort of 1 kilometre size, but there's less evidence as you get bigger with subwatersheds up to sort of basin size, and that's less empirical evidence is collected, and it's also hard to tease apart the effects of different components of land use and management. But it is something that is needed, is the empirical evidence. We tend to rely on models once we get up to that stage. And then host, I put host here. I think that host is a really powerful tool that was put together a couple of decades ago, and is the hydrology of soil types. But part of the power of the tool is the ability to link not only soils, but what's underneath the soils, how it links to the hydrogeology, as well as being linked to the runoff. And probably we need to think more about how we can utilize that tool to think about where we locate in the country natural flood management measures with regard to soils. Next slide, please. And then this is just some of the national data looking at the bulk density as a function of the soil organic matter fraction. And if we think that a lot of runoff tends to be generated once the soils get above about 1.2, 1.3 in terms of average bulk density, but particularly up to 1.4, 1.6. And that tends to be associated predominantly with the arable and horticultural. So most of the other soils and the other habitats are not as compact. So many of the problems and issues we deal with soils are to do with arable and horticultural systems and some of the improved grass. And one of the most recent countryside survey we've looked at, Laura Bentley's shown that organic carbon appears to be on the uptick, so increasing in these habitats. And so it'll be interesting to see whether we've seen a general decrease in bulk density and an increase in porosity across these sites. So thanks very much.
Thanks very much for that overview, David. That's a great scene setting. Yeah, again, keep your questions or pop them in the chat or keep them for a bit later on. So I'm going to hand straight over to Richard, who'll give us the perspective sort of from the ground up, as it were. Richard, if you're ready, over to you.
Thanks, everyone. I work in a team in the Environment Agency that deals with soils and floods. We have a specialist team in the southwest that's funded by local authority and the Environment Agency because we have a particular problem with surface water flooding from land. And that photograph in the background there just illustrates some of the things that we deal with to do with soil compaction mainly and runoff. And what I want to do is go through some of the learning, because I've been doing this now for nearly 30 years, and some of the things I've learned by dealing with these issues. So the next slide, Tilly. Okay, and the next slide. So is that yeah, so this is a case study example. I'll just let that go. Is that the video there, Tilly? So this is a typical surface water problem. So that is runoff from 4 fields. Okay. John, who's talking later on, wrote this up, got this published. But it's a case study example. I just wanted to show just the scale. So whilst David says we've got evidence at the plot scale and the field scale, what I want to get across, there's one thing I want to get across in this talk, is that this field scale really matters. Okay. There's huge amount of politics in the southwest dealing with these localized muddy floods from a few fields that wash off, that have never washed off in the past, and they wash into people's houses, onto roads, and cause localized problems. And that's why we have funding to deal with this. And so my talk is mainly about surface waters and the legislation that we have and that we are using, but it's not about catchment flooding. Okay, whereas I agree with David, having involved with all the DEFRA research that we did years ago, there's less evidence at the catchment scale, but we still have a problem. And I'll talk about this a bit more. So just the next slide. So the other thing I want to get across is that I think the awareness of natural soil hydrology is, and dare I say, quite low. This is a diagram that I've taken from a monograph by Soil Survey years ago, just really simplifying the runoff process and why soil type matters. Okay, because we hear about soils are unnaturally saturated and they can't accept rainfall. And that is the case. In fact, saturation, excess overland flow is a common, if not the most dominant runoff pathway in the UK, where you have soils that are wet either because they're stagno-glaze or groundwater glaze and have limited ability to accept rainfall. Okay, and that area at the bottom of the hill slope, which is either from through flow from Route 2 or Route 1, which is deeper, but those saturated soils at the base of the slope, that they are what is known as the contributing area. There's nothing new in this science. And this contributing area explains why we get floods downstream and why floodplains flood and why we have alluvial soils, because this has been going on since the Ice Age. Even in the wild wood, we had overland flow, and that's why alluvial soils have been laid down. And so the fact that we don't have much research evidence that we can affect the floodplain is no surprise to me, although we can make some difference. But where we can make the difference is further up the slope, where our research has shown that if soils are in good order, and by that I mean good soil structure and have good cover, they can accept heavy rain, the freely draining soils. Okay, so next slide. Now I just want to zoom into this. Okay, so here's an example of a catchment that I looked at on Friday during the heavy rain, and I'm pleased to say we're making some inroads here in this particular catchment. This is a typical example of a surface water flood with a large field. You can see the wash line in the middle, and then onto the road, and then down into the town and causing flood. No floodplains or fluvial. Okay, and this is where we're at doing work on these types of fields. And then the next slide, Tony. And so here's an example of a nearby catchment, which is fluvial. That's Powderham Castle there to the right, going on to the main. And the water in the foreground is the ex-estuary with the railway line overcrossing. Now, this fluvial flooding is really complicated. There's so many things going on that floods. Needless to say, that railway line's holding back water. But where I'm at with my work is the village in the distance there, Kenton, is forever being flooded, not in the floodplain. The schools having to be relocated because of the wash off. And these are freely draining soils. This is the Devon Redlands, sandy loam soils over sandstone, huge ability to accept rainfall. So next slide. So years ago, back in 1999, year 2000, I did some work with the former math. This was one of the early bit of research that we did when maize was just starting to take a grip in the southwest, where we did some research at which is now Rothamsted, which at the time was IGA, Institute of Grassland Environmental Research, and we thought we'd measure some runoff continuously on these freely draining soils, these redlands over the breccia, and we set up some replicated plots, and we've in the last 25 years we've done this numerous times on different soil types. But this particular piece of work was a game changer for me. It really changed the direction of my career, to be honest. Well, we set these trials up and we had a tipping bucket in those runoff traps, and we measured the runoff continuously for 3 months over the winter, having set these up and replicated. This was all published. And I remember at the time, the Bob Clements, who's retired now, rang me up, and this is the data he gave to me over the phone, and it just represents one rainfall event. It wasn't particularly heavy rainfall. And he said, loads of runoff coming from the compacted stubble, but nothing off the loosened stubble, which was chisel ploughed, which essentially means that the soil was ripped to the depth of the plough. And we had a cover crop in it there, and we had some undersown. The cover crop was direct drilled with a Unimore drill, and the undersowing was just sown once the crop had established its standard undersowing. And I remember, and the runoff from the compaction was just orders of magnitude higher. And people have misunderstood this. I mean, I've talked about this ad nauseum, this slide, but it's been largely misunderstood because people think, oh, the answer is just a chisel plough. When we did this up at Long Ashton, when Long Ashton was still going on the clays, the chisel plough made it worse because the chisel plough actually compacted the soil. So all the chisel plough did there was just remove the compaction. It didn't let the water into the soil and all this type of stuff. It just dealt with the compaction. So that runoff we were getting there from the 228 litres was unnatural runoff, enhanced by the compaction. And the chisel plough just restored the soil structure, interestingly, without any cover. And the cover crop caused all that runoff because it went into compaction. So it was direct drilled into compacted stubble. Okay, and the undersown caused less runoff, but there's still some runoff because of the compaction, again, following the harvest. So if we go to the next slide, this is just to illustrate what I'm talking about with these freely draining soils. So on the right-hand side, you've got good soil structure, and on the left-hand side, poor soil structure. And that's poor soil structure right throughout the profile, from the top where it's sealed through to relatively dense topsoil that's been loosened, but it's unstable. But that is a crop in there. And then you've got compacted subsoil. Whereas on the right-hand side, our work has shown that good soils and these freely draining soils have got a huge ability to soak up the rain. And so this is where we're at the moment with some current R&D. So next slide. So we've been doing these rainfall simulation plots. So we did this at Boscastle following the big storms. We did it at Ottery St Mary following the big storms, and we're now doing it towards Newton Poppleford. We've had some big storms, and what we're finding is that this is with Cranfield, but we're now doing it at the University of Plymouth. But these slides at Cranfield, we're finding that if the soil's in good order, so we simulated some heavy rain at Boscastle, okay, on grassland, some really good soil structure, and we simulated that event, and we only had 2% runoff. Okay, now that left-hand slide there, that's compacted grassland, we had 89% runoff. Now 2% runoff with 50 millimeters per hour versus 90% runoff at 50 millimeters per hour, as David says, a shed load of water. So we know at the field scale, these soils can absorb heavy rain, okay, providing the soil structure is good. So we're now doing this on the sandy soils again, and we've got some plots where we're using 75 millimeters per hour. And the early signs are that the good soil structure under grass is absorbing this rain. Okay, that's 75 millimeters per hour. So the next slide. So this is a storm we had a while ago. It's an interesting one. This caused widespread flooding from surface waters, a hailstorm, very similar intensities to Boscastle. And yeah, I lived this and surveyed the land afterwards. But what was interesting is how the hail here was like dye on the soil. And it's like we'd put a marker. And some fields had loads of runoff, and other fields didn't. And you could really see the wash off. And so what I did following this, spent 3 months after this event, I surveyed every field in this catchment. So I can't remember now if I've got the slide of the data for this. Next slide, Terry. I think, yeah. So here's an example upstream where I did this with Cranfield at the time, where we just looked at the soil structure and these are the different soil types. Okay, so you can see how the first take home from this is the range of soil types, and we looked at soil structure using a methodology that we developed with Cranfield, which is now essentially the visual assessment of soil structure, but it's looking at the state of soils in the topsoil and the subsoil. So the next slide, Tilly. So what Bob Palmer and myself did over a 10-year period is that we surveyed just under 3,500 sites. That's not all, that graph is not all the data, looking at the state of soils in relation to runoff. So severe means runoff in the field causing soil loss, so a gully or rills or sheet erosion. High means compaction showing signs of runoff but no soil loss, so grassland, for example. Moderate means there's some form of soil structure but no evidence of runoff, and low means good soil structure. And we found, looking at all these sites over a 10-year period in the West Country, that about 38% had poor enough soil structure in the winter. This is, remember, soil structure is a variable thing. So this is soil structure during the winter months. We found about just under 40% was causing enhanced runoff. And so we know in the West Country that we've got a widespread problem. We know it's localized, and we know that soils can absorb this type of stuff. So the next slide. So what are we doing about it? Well, this is what the team is doing. So those top two slides, I just want to illustrate this problem of timeliness. So that is the same field. Okay, the one on the left, they're both in maize. The one on the left caused runoff after that. So this is being plowed. So the soil has been plowed. They're both being plowed, but one is in slightly wet and one is dry. So what is happening there is not the ploughing that's the problem. It's that power harrow before, and not the power harrow, but it's the fact that the seedbed's going in when the soil is damp and it's packing it down. Okay. Whereas on the right-hand side, that soil's coming up wonderfully friable, huge strength, and the seedbed was wonderful. Now, everything being equal, I can tell you now the runoff from the right-hand side will be greater than the left-hand side, even though they're both ploughed. In fact, the cultivation is irrelevant. What we're finding, it is the timing and the state of the soil. Okay. And the bottom slide just shows examples of dealing with compaction in grassland. That is our own subsoiler that we purchased in the Environment Agency. And what we've been doing is doing demonstration work, R&D. It's not that we're providing a service to farmers, because that we're not allowed to do that type of thing. But what we've been doing is, for example, doing half a field like that on the right, and then showing farmers the benefits of sorting out the soil. Okay, and so last two slides. So this is an example. So this is a seed bed. This went in with direct drilling, and it could have gone in with plant. It doesn't really matter, but it just shows a typical example of runoff from a compacted seedbed. And we know that this is causing a problem on the freely draining soils and on the right-hand side. Sorry, next slide, Tilly, just to finish off. So this is the same catchment, same soil type, where the soil structure is really good. Early drills, crop coming up, accepting the rainfall. And so I went out and had a look at some of these fields on Friday during that heavy rain. And I'm pleased to say the fields that we've sorted out were not running. And some of the villages that have been flooded in the past were not flooded. Touch wood. I'll finish there.
Thanks, Richard. Thanks so much. I feel like you've given us a lot to think about, and we've got a bit closer to what the practical realities on the ground look like. Again, any questions, pop them in the chat. We'll save them up for Richard after our next two speakers. I'll pass straight over to John now. John, I couldn't see you for a minute because your name's come up as different, but that's absolutely fine. Don't worry about it at all. So thanks, Richard, and over to John.
Okay, can you see me now?
Perfectly fine. We can see you, we can hear you. Good.
I don't know why the label is wrong. I don't know who David Deeritz is, but anyway.
Not a problem. Don't worry at all.
I'm there. Right, next slide, please. 4 things I want to emphasise. The vulnerability of certain areas to erosion and flooding. Off-site damage by muddy runoff, strongly related to connectivity. Farmers may ignore even well-targeted advice. And well-planned mitigation measures do work, but have to be judged over time. So I'll try and illustrate these points in the next few minutes. I'll use work in Sussex done over the last 45 years. Next slide, please. So this is a map of fields with a history of erosion since 1987 in the Rother Valley, where I've been working in the last few years between Petersfield and Petworth. Next slide, please. Now that's not a random distribution, as erosion usually isn't. It relates to highly erodible soils, vulnerable crops such as potatoes, maize, winter cereals, vegetables in some cases in this area, and to slope and to farming practices. This is all to be expected, but this is why we get these closely, this kind of pattern of eroding fields, at least in this area. Now, unfortunately, 66% of the fields I've just shown you as dots on that map are potentially connected to freshwater systems and are therefore resulting in excessive pollution and high off-site costs. When I say potentially connected, what I mean by that phrase is that over the years we've been monitoring and recording them, they have connected at some time or other, those 66% of fields, to the freshwater system, the River Rother. If we want to address the issue of off-site damage, that's muddy flooding, freshwater pollution, etc., we have to look at connectivity, that is connectivity between fields and the at-risk sites. What has been poorly researched is the question of how many and where mitigation measures are needed to have significant impact, and I'll come to that in a few moments. Next, please. This was a map done a few years ago. Actually, it was done to look at the relationship between allegedly high-risk sites on the basis of slope, soil type, and what crops were being grown, and erosion. And it produced quite a high correlation between what the model was telling us, which is a very simple DEFRA model, using slope, soils, etc., and where the erosion which I mapped was. The surprise here is that the observations of muddy runoff going into the River Rother, and I think there are 6 or 7 points with blue circles showing where the material was getting into the Rother. Now, before I did this work, I wasn't aware that there was such a close connection between eroding fields and, in this case, a vulnerable river. Next, please. One of the ways in which connectivity is enhanced in many areas of southern England, perhaps it's a surprise to some of you, but certainly a problem in Sussex, is the existence of sunken lanes connecting fields on the valley sides to the river itself. These are quite important connection routes. You note the small landslip on the side of this one. Next, please. This is a map to push to say just a little more about erosion, connectivity, showing observed connections between fields and the river, thus flow of water and sediments near Petworth. And this is based on observations. Note the role of ditches and drains in this map. The ditches are clearly visible because they're the straight lines along which sediment flows along the edges of the fields. Ditches usually cleaned out in winter, made more efficient, and here you go. After a winter storm, they're acting as they should do and transmitting sediment and, of course, agricultural pollutants to the river. One more point about this is that we tend to assume that hedges in the British landscape are very effective at preventing flow between fields themselves. This is not always the case. In fact, it's not often the case. Usually sediment and runoff finds a way through hedges, so they're pervious rather than impervious. Often, if I'm speaking on the continent, people say, well, the English landscape is full of hedges, you don't have a problem, do you? I'm afraid that's not always the case. Next, please. Now, I think this is my most important slide. Mitigation, we're often asked, I'm often asked anyway, about mitigation measures. What effect do they have on sediment reaching a river? And how many do we need and where should we put them? These are big questions in terms of preventing flooding and soil conservation. And unfortunately, in my experience in Britain, we don't have good information on this, even for the relatively small catchments or medium-sized catchments, where we would think we would have that information. So back to Belgium, where I've done a lot of work with Karel van Daal in Flanders. And on the right is a catchment that he has managed for over 20 years. And he's been able to advise farmers where to put mitigation measures. That's all the little green strips on the map, vegetated buffer strips and earth dams, etc. These have been put in over 20 years, at least 20 years. And this is important, with funding from the government, the national government and the provincial governments, which we don't really have in Britain, do we? Not compared to this anyway. So we can ask the question, with 20 years of putting these mitigation measures in, do they work? And on the left, the little table shows that they do. So if you look at mean sediment yields at two sites in the catchment, downstream and upstream, and you compare the ones nearly 20 years ago with more recent ones, then you'll see that sediment yield has been significantly reduced between those two dates as the mitigation measures have taken effect. So this, I think, is good evidence, good proof that if we put enough mitigation measures in and put them in the right places, we can have a significant impact on runoff, especially muddy flows that were affecting the villages in the north of that map that you can see there. Next, please. One point I made at the beginning is the issue of, do farmers follow advice? And in some cases they certainly don't. And my example is post-harvest maize fields. This is not what we want to see, with virtually no cover in November. Next, please. I did a survey a few years ago of 18 maize fields that I could find in the Rother Valley in Sussex. And it turned out that, and this is the list, of 13 of them out of 18 were non-compliant with DEFRA advice. And DEFRA advice says you should be ploughing up after maize harvest, or you should be putting a cover crop in, or you should be subsoiling. There are various measures, or planting your maize earlier so that you are not working these fields when it's wet in November, and therefore unable to do much that's useful on them. So this is an issue, and I'm sure Richard Smith will have plenty to say about this, in terms of getting better advice, or even compelling, dare I say, farmers not to do this sort of thing in order to prevent runoff and erosion occurring. Next, please. And my final point is that the risk of erosion, runoff and flooding in arable UK is largely in autumn and early winter, with the coincidence of bare ground, a lot of winter cereals, and moderate and heavy rainfall. Now, the point about winter cereals isn't that they are particularly erodible. They are not compared to maize, potatoes, etc., but they are widespread. And especially there's an issue of connectivity often between winter cereal fields, with many of them in blocks, and therefore travel of runoff from one to another. So this autumn planting of particularly winter cereals can be quite an issue in our country. This field, for example, on the South Downs, eroded 6 times in 10 years. And you can't tell me the farmer who lives just off the picture wasn't aware of this. He certainly didn't do anything about it, and continued to take the risk of growing winter cereals on these fertile soils and hoping that this sort of thing would not happen. Next, please. So, conclusions. We have to accept that some easily identified sites, I would say, are high risk in terms of runoff and erosion. And the work that Richard Smith and I have done in Devon recently of maize sites on steep slopes on erodible soils is an illustration of this issue. We need to better educate farmers and maybe penalise those that ignore advice. We need to address the connectivity issues with mitigation measures, and most importantly, we need to do some monitoring to see if these measures work, especially in terms of the effect on freshwater pollution of muddy flows from fields. Thank you very much. There's some references for anybody who wants them at the end. Thank you.
Thanks so much, John. That's really helpful. And also, we will also present the slides from the presentations given on the LUNS website, so you'll be able to access all of those really helpful references. Yeah, that was a really vivid presentation, one that gives us more critical context and considerations around this issue. So thanks again. I'm going to hand straight over to Alejandro, over to you.
Thanks, Didi. And actually, you did a very good job with my surname. Thanks for having me here. Great to be here and share tidbits of work that we've been doing the last few years. This is a team that has worked in several projects, including Landwise NFM and a couple of European projects on the sponge function of landscapes. Next, please. So just to go through just a couple of slides of some of the output from one of the three big NFM natural flood management projects funded between 2017 2021. Landwise was led by the University of Reading, but CH contributed with the soil surveys of many sites in the Upper Thames from different characteristics of soils and slope and land use. Just going to show a couple of outputs from that work led by James Blake. Next one, please. So the idea was to have first a broad-scale survey of 164 fields to measure properties of the soil that influence storage of water below ground, so bulk density, texture, structure, soil organic matter, water content, and vegetation type, focusing mostly on the soil surface, the top 50 millimeters. And then from those 164, a detailed survey of 3 locations, 7 fields, where there was more in-depth measurement of properties of soil, infiltration in the field, water storage over time, estimating hydraulic conductivity in the field at the surface and also the subsurface, and soil organic matter, and measure changes in soil water across larger areas and with depth and across a few years. So that's the map of all the sites. The broad scale survey, just a few examples of the field observations. Just to add to what Richard and John were saying before, that is a picture on the right where you can see, hopefully, that the underlying soil is not wet, but the top 5 millimeters is really compacted and really wet, and basically a consequence of how the field is being worked at in this heavy clay soil. Next one, please. And following also a little bit what David was saying before, or the team did a analysis of the broad scale survey, that top 5 centimeters of soil, and this is a graph that summarizes what happens with or what was the results for the estimated porosity from the bulk density and soil organic matter, and you can see very clearly things that we know, that there's the increasing soil organic matter increases the soil porosity. These are for all conditions. I should have said that the fields were sampled in a way that we had points in the infield where the crops are, in the tracks where there's trafficked conditions, and also at the margin, so that we can compare what happens in different areas of the field. But these points are all together, and you can see that for just a relatively a modest increase in soil organic matter, you get a quite significant increase in estimated porosity. Come back to that probably in discussion. Next, please. So one of the projects we are working on, taking a few of these sites further in time and connecting to John's comment that we need to monitor what happens in longer term. In these 4-year projects called Spongecapes, we took a few of these agricultural sites in the Upper Thames with regenerative agriculture and one control, to see how the system develops, how the soil has improved or not, and the water retention capacity or the sponge function of these agricultural landscapes. Next, please. So we have a traditional rotational crop, a few regenerative agricultural practices sites, one with infield buffer strips, cover crop, and control traffic, and one wooded and one regenerative grassland site. And most of these sites have water logging as the main challenge. And we looked at, as the picture shows below, looking at continuing the monitoring of infiltration, soil organic matter, percolation, and porosity and the water retention characteristic curves. Next, please. So there's a lot of results coming out, but I just wanted to concentrate on a couple. On the right first is one of the sites which has a combined measures of controlled traffic and winter cover crop, or green cover as they call it in Europe, looking at what has happened between 2021 and 2024 at the top 5 centimeters. If you look at the bottom scale, is 0 to 5, 25 to 30, and 45 to 50 centimeters. And the brown is 2021 and the green is 2024. And just looking at the 25 to 30 soil depth, the middle band, you can see that the soil organic matter has increased 1 to 2%. This is for the 15 sites or the 15 locations in the field on average. And on the left, we wanted to look at some data which is a little bit more longer term from sites that we had installed EdiFlux towers or Cosmos, these cosmic ray neutron sensor sites for for monitoring soil water, soil moisture. And we saw that those that were installed in a regenerative agricultural site, actually in 10 years, there has been an increase, a substantial increase of the maximum amount of water, of soil moisture, that soil can store. And this is important because an extra 5% of volumetric water content capacity in a 1 meter deep soil in a hectare, it really amounts to a lot of storage. Next, please. So that's it. Just wanted to mention that this is part of a bigger team work that we are trying to look at fluvial and agricultural landscapes and how previous projects we can continue in time and see how the, in this case, soil properties develop. I didn't mention that on the sites also the infiltration capacity and the percolation rates measured as the saturated hydraulic conductivity at the surface and at the subsurface also has been improving. Thank you.
Thanks so much, Alejandro. It was really, really interesting. I'm looking forward to seeing how the discussion now develops between the four of you. And I'll hand over to Pete, my co-lead here, to lead that part of the workshop. Maybe Tilly, you could pop up the...
Thanks, Ellie. Yeah, so we've got a partial answer to some of these from those four excellent presentations, so thank you very much. But I'm still going to ask these questions, and I'm going to come to all four of you, but I'll ask probably one of you first to answer these questions as we go through. I'm just putting these up so you can have a quick look in advance about the sort of questions we're going to be asking. How does the soil type, soil properties, and soil management influence susceptibility to flooding? The second question is, what are the strategies, including nature-based solutions, that can help reduce or mitigate flooding and flood risk? I should say, I'll ask, I think first go for the first question. I'll come to you, David. For the strategies, I think John Boardman mentioned some, in the Belgian study, he mentioned some solutions being put in place. So I'll come to John first for that one, but you can all chip in. In which areas could government help in terms of policy or funding, and where might it do this most effectively? I'll come to you, Richard, for that one first. Are there policy or research gaps that need to be filled? I'll come to you first for that one, Alejandro. How strong and/or useful are the links between policymakers and private sector stakeholders, such as water companies, with respect to flood risk? I'll come to you first for that one, Richard. How do we build evidence to support investment in soil-based solutions? I think I'll come to Alejandro for that one. And are there any decision support tools or early warning systems that can alleviate flood risk? I'll come to you, David, to that one first. Okay, so we've got about 50 minutes or 55 minutes to cover those questions. And just because I asked one person first doesn't mean you can't chip in. So just raise your hand or just chip in when the first person's finished speaking. So we'll get going. We'll go into gallery mode so that we can all see each other. And I'll get the questions open. So first off, how do soil type, soil properties and soil management influence susceptibility to flooding? David, would you like to kick us off with that one?
Not a small question.
No, easy one to start with.
So, yeah, Richard's probably, maybe we can tag team this one, Richard. It's, I think one of the things, so clearly different soil types have different hydraulic properties. And I think one of the things I was trying to convey in what I was saying was this need to look at a systems approach. And I think that came through very much from what John was saying as well. And that idea of looking at the system, both the properties of the soils in terms of things like infiltration, compaction, but also that connectivity in the landscape is critical. And then when you see management, is the management making that worse or is it making it better? And I think John brought that out very nicely. One of the things that struck me very much from Richard's talk and the slide, I think you said, Richard, it was probably the most important slide that you presented with those results from those experiments. And you made the point that chisel ploughing is probably not the solution by itself. And you seem to get much higher with cover crops, runoff, what have you. And that's perhaps not intuitive to people. And I think one of the really critical points from that is, especially with restoration, is that there is a sequence of events that you probably need to go through, and you need to get that sequence right in order to correct the system. So what Richard was showing, if you plant a cover crop, into a soil that's already compacted, you're still going to get runoff. So if some of the work that we've been doing was showing that sequence becomes really important, and perhaps you need to go in there with metal, perhaps you need to lift the soil in some way. But once you've done that, you don't want to just leave it to go back to where it was. But that's when you go in with perhaps organic matter with a cover crop, and then you try to maintain that change in structure with restoration. And some of the theoretical work that we've been doing is showing the importance of changing the shape of the geometry of the soils and maintaining that. And you see, as soils gain more organic matter, generally the porosity increases, but that porosity is maintained by changing the shape of the grains within the soil. And I think that's what, some of what comes out of what Richard was presenting is very important. So I'm going to leave the next bit to Richard.
Yeah, can I just jump in there? Because I noticed in Alejandro's presentation that cover cropping was one of the things that was leading to that higher soil organic matter. So is it really just the difference between the two? Part as a component of regenerative agriculture, cover crops seem to be a good thing, Alejandro showed. And Richard was showing that by themselves, when planted into already compacted soil, it's not such a good thing. So is it really to do with that?
It's a systems approach.
It's
what David was saying. It's, for example, what I was showing, it was not only the cover crop. It was a combination of cover crop, controlled traffic, and caring for the soil as a system.
Soils saturate. So where I'm at with this, and want to get across, we're still not talking soil type. So if the soils naturally saturate, like the clays or the organic soils, your peats, your organic soils, and they are surface water glaze or groundwater glaze, and they saturate to the surface, I fear that the cropping and the organic matter is a bit of a red herring, okay, because they're saturated. And we just need to focus on the hydrology here as opposed to the sediment. And so I'm not talking about pollution and soil loss and sediment loss. I'm just talking about the volume of water that's causing the floods. And so to answer the question about soil type is absolutely fundamental in this work. I can't emphasize that enough. How a chalkland soil is different from a sandy soil, how an organomineral soil, a clay soil, a cracking clay, a groundwater glaze, they really matter in terms of how they generate natural overland flow. Okay, and every catchment has saturated soils that cause natural flooding. And so arguably, and this is what the agriculturalists are saying, this is where we were at in soil survey in the 80s, is that drainage of these probably one of the best things you can do to desaturate, desaturation not the right word, but to lower the groundwater or to make these soils accept rainfall so you don't get the overland flow. And so then what happens is that water percolates through the soil to the land drains, but then you've got a counter problem, is that your secondary drainage, i.e. your ditches and the arterial network, increase the runoff. So on the one hand, by turning a slowly draining soil into a more freely draining soil, which is the whole point of drainage, is a good thing. But on the other hand, you need a land drain going to a ditch, which then speeds up the runoff. There is actually a holy grail. We have both, where you slow the runoff, the connectivity thing that John was talking about, John Boardman, but we can talk about that later. But the soil type really matters. And it's overlooked in a lot of the research. So we found with the clay soils, the solutions are different and the hydrology is different compared to the free draining soils. So I just can't emphasize it enough, really.
David, do you want to come in there?
Yeah, just adding on what Richard said about that hydrological component. The water's got to go somewhere. And if you can improve a soil and you can percolate water down, then also it depends on whether that water is faced by an impermeable layer or a permeable layer. So if we have a sort of permeable aquifer that we can move water down through the profile and we can move it into recharge, then that's really advantageous. If we are in catchments where it's tight and it's impervious, that water is just going to run off. It's got nowhere to go once it gets down there, and you're limited by the storage capacity essentially of the soil. And that's that interconnection. So as Richard says, soil type is absolutely critical, and what the soil type is sitting on and how it's connected into the subsurface is also critical, which was where that host model, I think, is very useful in thinking about what does my soil sit on and what do I want to be able to achieve with it.
Brilliant.
It just so
Thanks,
happens
David.
in the West Country, we've got, it's about 60% of our soils, I've done the numbers, are freely draining soil. At the soils, we didn't have the glacial till in Devon and Cornwall, the clay, boulder clay that covers so much of, that mantles a lot of England. We've got a lot of brown earths in the southwest, freely, as has Wales, freely draining brown earth soils. About 60% of the land. We have got clays as well, of course, in North Devon, but a lot of Cornwall, South Devon, and around Exeter is free, either over slate or sandstone or breccia. These are freely draining soils that have huge ability to absorb rainfall, and they don't need land drainage when they're in good order. But they're also very easy to temporarily, irrespective of organic matter. I think that's we've shown that the soils with high organic matter produce just as much runoff as those with low if they're compacted. So and that soil compaction, poor soil structure is a transient thing that's down to management at the end of the day. Whether you've got horses, people, football pitches, development, you name it, all generating runoff from freely draining soils. Farming is just one part of the problem. And I don't blame farmers, far from it. It's just the pressure they're under. So it's so easy to plant up a landscape these days with no time and to get it less than ideal. And that's what happens.
Brilliant. Thank you, Richard. Alejandro, I noticed you put a couple of things in the chat. Do you want to just, before we move to John on the next question, just want to finish that off?
No, I think we are more or less on the same page in the sense that it is it depends on the context and of the soil vertically, properties, layers, the slope, how it is managed. So yeah, you have to be you have to know the place and what can be the factors that affect whether it's runoff or not.
Brilliant. Thank you very much, all. Let's move to the next question in the so that we can stay on time and try and get through all of them. I'll come to John first for this one. And the question is, what are the strategies, including nature-based solutions, that can help reduce or mitigate flooding and flood risk? John, do you want to kick us off with that one?
Yes, and I'm not sure that the Belgian analogy is the most useful because it's a bit of a different situation. Virtually all the soils are loess and highly erodible. So and they crust easily. So there's a significant difference. Now, most of the mitigation measures, which are buffer strips and retention ponds, have been put in initially to prevent muddy flooding reaching villages. That was the reason they went down that route. They were not put in to prevent erosion on the fields, and they do to a certain extent do that because they break down the connectivity. So you're detaining water at many places in the landscape and not allowing it to move in greater quantities onto the next field. So to that extent, they do reduce erosion. Now, one other thing I'd add about the Belgian situation and mitigation measures is that cover crops are compulsory in Belgium. You have to have a cover crop on your post-harvest fields. Otherwise, you can get fined. And that was brought in purely to try to soak up nitrates, to reduce the nitrate load that they didn't want. But I think an unintended consequence is cutting down winter erosion. So again, I'm not quite sure how this experience, that I think is very impressive, especially with the funding that goes with it, is highly relevant to the British situation, unfortunately. Right, thank you.
Great, thank you, John. Anybody want to come in on that? So there were a range of possible solutions that you've all presented. We covered some of them in the last question. It's not about doing one thing; it's about getting all the things right, taking a systems approach. There's an interesting perspective, I thought, John, on the infield erosion versus the muddy flooding. We're looking at two different processes there, aren't we? And we're tending to lump them all in together.
Yes, and there's a danger in that, though. Of course, they are linked to some extent, but there is a danger. We have to design. We often design mitigation measures either to prevent downstream flooding or to prevent erosion on the field, but sometimes they can be linked.
Yeah, thank you very much. David, do you want to come in?
Yeah, I think it's worth saying as well that with natural flood management, you have a whole suite of different measures, and many focused on soil management, which might be more appropriate at the field scale. But then as you go up in scale, there's potentially other management measures that may be more effective as you increase in scale. So holding water up, barriers in the rivers to affect the phasing of how catchments link together, producing flooding at bigger scales. So it's thinking that these measures, different measures might go across different scales, and different types of measure may well be important across scales.
Can I butt in and ask a question? This is John again. My impression, and it may be a misguided impression, is that much of the natural flood management experiences in Britain are related to grazed or upland catchments, and not so much to the arable catchments that people like myself and Richard Smith have worked on. And I'd see that as a problem, but I may just be misinformed about this. Perhaps somebody could comment on it.
Well, I think that's my impression also. It does seem when you look at the literature, there's very few, from what I can see, studies that look hard at the sort of lowland
yes,
systems.
Absolutely.
And all our paired catchment studies, I mean, if you take, for example, Plynlimon, our long-standing paired catchment study is uplands. Quite a few of the others are all uplands to do with water management and yield. And they've not been particularly focused on this issue. And lowland catchments, I mean, DEFRA has a number of demonstration test catchments, but the evidence, I think, is not where it should be or could be.
Well, that's what I'd be saying too. I think we're tending to neglect the arable areas where there are significant problems, particularly those growing high value crops intensively, and where we've got quite a lot of freshwater pollution in those areas. And maybe that for me is where the Belgian experience is quite useful, because they are dealing specifically with highly arabilized catchments. Thanks.
Pete, I'll just come in. I've got a few points. It's back to soil type for me. So we are doing both the soil and the NFM measures. And so we've got an NFM scheme on the heavier soils. So where you have natural runoff, okay, I'm talking about from saturated soils, and you need to make space for water, and that's a term we use in the Environment Agency, because you're going to get the runoff, okay, and so it's got to go somewhere if you want to stop the flooding. And so this is where you store the water above ground, because you can't store it in the ground, or you slow it down.
Mm.
So this is where you need to put things in drainage areas, natural drainage ditches. You slow the natural flow down, okay, because that's all you can do, because you can't get more in the soil. And increasing organic matters, it'll do, we all want more organic matter, but it's not going to deal with these big floods. So the natural flood management, making space for water, I would argue, is for the poorly draining soils. For the freely draining soils that John has been talking about on the downs, in Flanders on their lowest soils, in the West Country, that's where the soil management is, because you don't want the runoff in the first place. And you should not be thinking about, let's build a pond to stop soil erosion, because that's not sustainable, because you're losing soil. So for me, it's about context again. It's not one or the other. It's about knowing your soil type.
Excellent. Thank you. Any other comments on this topic, or shall we move on to the next?
Pete, can I just come in with
Ellie, go on. Yeah, please do.
Yeah. I mean, at the SSA, we often talk to, in fact, we responded to a government consultation on flooding. We spoke to most of the panelists here today, and I feel like there's still an unresolved, I don't know if it was a tension or just not a joined up way of talking about the influence of soil organic matter and flooding. So I just wondered whether we could just dwell on that for a minute. Will increasing soil organic matter reduce flood risk? Is that where we should be looking, or is that contextual in different places in terms of what kind of takeaway can we get from this conversation?
It's very difficult to do in arable systems. To increase organic matter, except over long periods of time with a lot of grass into the rotation. So it's a challenge for arable systems, isn't it?
Alejandro shows regenerative farming, using controlled traffic, cover crops, and what was the other one? There was another one, Alejandro. It did increase the organic matter quite considerably, didn't it, over 3 years?
Yeah, 1 to 2% in 3 years.
That's impressive.
But that's our best example, though.
In the West Country, again, it's soil type specific, okay, Ellie. And we need to be clear as well about the hydrology. So I'm with John on this, that it's difficult on the sandy soils. Okay, so the light soils that causes so much problem in the West Country that easily erode because they cap and they compact, they pack down. My own view is I don't think you'll get the organic matter up high enough to make a difference for these dispersive soils. You'll make a difference, and I'm not saying it will not reduce the bulk density, but putting aside the controlled traffic, because that's something that's different. But the organic matter in its own right will never get high enough on the sandy soils to make them resilient to a storm. I mean, one of the storms we dealt with over at Newton Popperford, we had 100 millimeters in 2 hours. Okay, and we had tremendous wash. In fact, that was that video. I don't think the organic matter will make diddly squat difference to that.
Yeah,
which is and I'm focusing in on the problem as opposed to organic matter. The problem being floods, okay, and mud in people's houses, and the only real resilient answer to that community is a change of land use, and that's what
yes.
It's not raising the organic matter by 1%. It's not controlled traffic. It's actually for this community that's getting these floods, we have to think a bit more radical.
Yeah, taking that systems approach, Richard. Yeah, it's really important.
Yeah.
So there are some situations where it just won't help, but I'm getting the impression that increasing the organic matter generally will lower bulk density and improve the water holding capacity, blah de blah de blah.
Yeah.
So it's a good thing to do, but it's not enough in itself. It's not going to be, increased soil organic matter problem solved. Is that right?
Correct.
Yes, for
Yes.
flooding. Yes, and bearing in mind that a lot of where the evidence is at a local scale. And bearing in mind we have natural runoff. I'm not saying we don't want to increase organic matter, we do. But out of all our armory for dealing with floods, it's right low on my list for me personally.
Richard, can you build out what you said about change of land use? I mean, bearing in mind Lunds is land zero. So how would you kind of unpack that?
So there's a question here before I come on to that. Was that a question about organic matter?
No, land use change.
Yeah. You mentioned land use change, Richard. So
okay, sorry.
What would that look like?
Yeah, sorry, I could just see some hands raised, that's all. But so yeah, Ellie, to answer your question about land use change. So the examples that we're dealing with are where you change from arable to permanent pasture. Okay. Oh, ideally, I mean, the holy grail would be to stop farming in these small areas where you've got these critical areas where the off-site cost is just too much for people and property and livelihoods. And we can map these areas, and we do map them. We have soil maps, we have overland flow pathways, we have LiDAR, we have risk maps, and we are now talking to farmers in our project saying, for these 4 fields, the risk is with you. If you want to carry on with these high risk crops, do so. But if we get a flood, we will be taking enforcement action because this was foreseeable. And in our view, would be once the awareness is raised, is negligent. And so we would want, I'm not saying everywhere, for critical areas, and we need to help farmers identify these critical areas, we are saying change the land use out of arable. And that's not, so if we go into permanent pasture, we know that they're not immune, permanent pasture. You can still batter the ground, you can still do silly things and correct, even with woodland, depending on how it's used with footpaths and people and pressure. I've got lots of examples in the West Country where farmers are doing different things to protect property. So to answer your question, Ellie, it would be arable to grass to semi-natural habitats in that order of priority, with the semi-natural habitats being the holy grail. In critical areas where we're talking 3 fields, and we're talking surface water, localized flooding, not flooding of Birmingham or Exeter, not at that scale. I'm talking about at the local scale.
Yeah,
Start
brilliant.
local,
Thank you, Richard.
build up.
Thanks, Richard. I'd like to bring in Alejandro and then David.
No, I think the idea of tailoring and to be focused about where, and going back to what John was saying also before, where and what. So thinking a larger scale, probably there's areas in the uplands where we need to kind of renaturalize and protect the better productivity croplands in the lowlands, and therefore have a more intelligent approach to how we manage the landscape. But I was also going to chip in saying that it's not about soil organic matter. I think soil organic matter is one of the indicators or one of the things that can be important, but it depends on the context. And actually, it's not soil organic matter by itself either, but it also relates to other things that might be important. So, for example, the macropore formation because of soil worms and how that might break or help break some restricting layers and therefore promote infiltration and deeper percolation. So, yeah, we shouldn't. I guess my bottom line, we shouldn't just think of in one dimension here. Is again a system, and you have to look at several aspects together.
Great, thank you. David?
Yeah, I think I just nuance a little bit that discussion of soil organic matter and change in land use, because if you look at the final slide that I presented that showed the national levels of porosity and it was bulk density, but porosity is the same factor really, with the organic matter. As you increase in organic matter, you are increasing the porosity. And so, of course, if you change from one land use to another, in essence, you're changing the amount of organic matter in the soil and you are changing the porosity. So that change in land use, one of the factors it changes is an increase in the organic matter. And as Alejandro says, it brings in other factors as well, like it might be earthworms, it might be the rooting structures in woodlands that really can fracture the subsurface and create flow paths downwards. One of the problems with crops is that there's a switch with roots, so that if you've got herbaceous roots, they will tend to follow the pore structure that is there already. So if you plant herbaceous plants into compacted soil, the roots will just be following whatever pores are available. But it takes woody roots in general that are bigger than a certain size threshold to actually lift the soil and make changes and burrow through compacted layers. So thinking about and understanding how those different factors, both the organic matter and the mechanical action of the plants themselves, they all come together and need to be thought of in that systematic approach.
Brilliant, thank you. Before we move on to the next question, Tom has got his hand raised. Tom, please.
Yeah, thanks, Pete. I thought I would just come in and support the use of woodland as a measure to help reduce rapid runoff. As has been mentioned, strategic placement of woodlands, I think, has been shown to be effective. I'm not sure if I'm getting feedback. Sorry, I'm getting a bit of feedback. Not sure if you can hear me. So I think woodland is a sound measure in terms of increasing rooting and affecting runoff pathways, but also the ability of woodland to, particular things like conifer woodland, to increase evaporation loss to intercept rainfall during storm events. Lancaster University have shown how significant that can be during events. So just to support the targeted use of woodlands for not just flood risk management, but obviously that's been driven forward by carbon and everything else. And then, sorry, just one other final point. I was going to come in earlier with Richard's point about focusing on the freely drained soils. I would just say that it is possible, fairly straightforward, to destroy the macroporosity of organic soils and wet soils. So you need to be careful across all soil types, and it's very easy to compact and surface down and impact on increase that saturation or speed to saturation in poorly drained soils if you get the management wrong. Thank you.
Brilliant, thank you, Tom. Let's take another question. This one I'll put to Richard first. And in what areas could government help in terms of policy or funding, and where might it look to be most where might it look to do that most effectively? So what could government at various levels, or its its arm's length agencies like the Environment Agency, what could it do in terms of funding or policy to help solve this issue? Richard.
Okay, it's a fairly awkward question for me, Pete, working for the government and fully funded by the government.
You prefer to pass on that one, Richard?
No, I've got my own views, and I mean I can't about what more can be done. Just wanted to give it a bit of context. I mean, at the end of the day, we have a lot of power. I'm not talking about now in Wales or in Scotland or Northern Ireland, but in England, we have the Environment Agency, we have a lot of powers, okay, to deal with this type of stuff, for pollution, not for flooding, okay. And so we have rules for soil erosion that are very powerful, and we're using them, okay. And we have now far more resource than when I first started, okay. In the Environment Agency, we have a new regulatory team of, I can't remember how many officers have been employed in the last 3 years, but it's in the order of 30, maybe 40, dealing specifically with regulatory issues, okay. And gradually soil coming on. So we started with dealing with pollution, nutrients, diffuse pollution, but soils are becoming more of a focus. So all I'm saying is where we're at, okay, Pete, as opposed to what do we need, okay. I just want to get it across to say the things we have. So we have regulation, we have advice, we have catchment sensitive farming. In the West Country, we have a plethora of schemes dealing with NFM for diffuse pollution, and with our partners, catchment-based approach. Okay, I work in a partnership team. Okay, so I just want to get across this view that we're not doing much. Well, I can't speak for the rest of the country, but in the West Country, we're doing a lot. Okay, and I think if there's one thing that I would like to get across is that, for me, it feels nationally really disjointed. Okay, that's my personal view, and I'm as guilty as any.
Do you mean nationally?
Getting me out of Devon is hard.
Richard,
I don't go around the country.
Do you mean nationally within England, or you mean between the different countries of the UK? You mean even more localised than that, like Devon versus Cornwall?
Let's start in England first. Relatively disconnected. I'm talking about the floods now and the science, even more so between Scotland, Wales, and Northern Ireland. And this workshop is great for pulling this all together. I would say that's probably, for me, where the issue is the fact that it's combine our knowledge and think local as well. But you've got to, and so I'm trying to be diplomatic here. We have the regs. Maybe we could do a bit more with floods. Sometimes we've on our enforcement panel thought long and hard about some of the big floods that we've dealt with. Is it appropriate to go to court with pollution legislation when actually the issue is flooding? It's not easy. We can technically, because the technical offence is causing soil erosion, no measures in place. But we might not if there's loads of runoff elsewhere in the context and it was a big storm, because it wouldn't go down well in court. So you could argue perhaps the legislation needs revisiting when it comes to soils and flooding. But we have legislation, we have advice, we have schemes. We're just not joined up.
Brilliant. Thank you, Richard. Anybody else want to come in on that? I mean, I noticed, Richard, you said earlier on about telling that farmer about the 4 fields, and if they don't do anything about it, you could go back later when a problem does occur. And John, you also mentioned that one of the things that you were suggesting, if the farmers don't take advice, there should be some punitive measures. So those are similar things which partly exists for the Environment Agency.
Yeah, and we're doing that.
So
So John, you go first.
Well, I think the word you used, Richard, disjointed, is one I'd come back to, because in Sussex, where I've been working for years, there are, as you said, many organisations in theory working in parallel on these flooding and pollution issues, but they don't seem to talk to each other. There's a lot of overlap and there's a lot of gaps. Unlike parts of the country, we have a non-functioning catchment sensitive farming that's not working, and we have non-functioning farmer clusters that's not working. For years we've had a rivers trust that's not been functioning. I see signs of life now, and I'm hoping that now they've got a bit of money from the national park, they're going to lead the way into a brighter future. But these gaps and the lack of talking to each other has been a major issue. We did a book last year on the Rother Valley, and in the final chapter we were looking at the future, and we kept coming back to this issue of there are many people working in this area, but they are not talking to each other.
David?
Yeah, I was just going to mention expectation management, because when you look at that information that's come through from the Met Office, and you think that, you know, these extreme events, I mean, John mentioned the importance of October, November, December in terms of timing for these sorts of events.
Yep.
And that's exactly the time that we've seen this 60% increase in storms above 50 millimeters occurring over the last century. And if that's now going to increase by another 60 to 80% over the next century, then we start making measures. As Richard said, we do more and more work, but the more work that we do, we're still having to combat the situation getting worse and worse. And at best, we might be able to hold the line. And so if we do nothing, for sure it's going to get worse. But all the effort that we put in, the results of that may just be that we kind of hold the system in the state that we're in, rather than seeing large improvements. And I think from a policy perspective, that's something that's important to consider.
Well, some things are changing as well as the climate. I mean, maize is spreading in the southwest, as Richard would tell you, and that puts more and more sites at risk of flooding and pollution. So it's not just increase in numbers of storms in the autumn that is an important factor, but land use change is also an important factor.
Great, thank you very much. Shall we move on to the next question?
Butted in.
Yeah, no, thank you for that, John. The next question, I'm going to come to you first, Alejandro, with this one. What are the main research gaps and policy gaps that need to be filled, do you think?
Oof, that's a big one too. But I think just to take a couple of research gaps, I think as David, I think at the beginning really framed very well, we know quite a bit when we have good evidence at the local scale, plot scale, even field scale. But once you start upscaling, what is the impact of measures where and which further downstream on flood risk we are lacking, and we rely on models that are parameterized with parameters that we tend to think that are fixed. And we know that the soil properties change year to year, season to season, depending on land management, etc. So there is a big gap there, in my opinion. Policy, I will just repeat something that the farmers told us. We did quite a few surveys, questionnaires, face to face. And there were some examples of farmers that had done a big investment, for example, buying a direct drill because of advice. And unfortunately, the advice was biased by being from the providers of this machinery instead of more unbiased opinions from, for example, what probably Richard does in the West Country, but perhaps there's some other areas where the access to that expertise is not there, and unfortunately they make bad decisions, and they backtrack and get frustrated and say, oh, you know, this is not working, and we'll go back to our previous way of doing things.
Anybody else like to come in there on research gaps or policy gaps?
I think so Pete, I'll come in on the research. So where we're doing research at the moment with DEFRA funded research with our partners is the big storms. Okay, so those papers, my talk was based on work that I've done with Cranfield. Some of that is not published. Okay, there's contracts we've done with them, and so we're now repeating a lot of this work that I did 20 years ago in an academic environment to get the robustness. Okay, so and the question that I'm asking of the university is, how far can we push the soil, these freely draining soils, with this extreme rain? Because we at the coalface, we have the view of the public is that a lot of these floods are because of farming. Okay, that is very common. And so I get beaten up on the side of the face by the public when I go out. And then you go and talk to the farmer and they say, well, it's act of God and it rained. What the hell can we do when you get 100 millimeters of rain? Nothing we can do. And then they have a go at me on the other side of my face. And, I'm using this analogy because that's what one member of the public said to me. Looks like you're really beaten up from both sides. And I'd also argue that I've beaten up internally as well. But so we just need the research, okay, and both the academic community, the hydrologists, the Met Office, to get our thinking straight with these big storms. So if we have the rain that we had in Spain, for example, last year and ahead this year, where you saw at Valencia, these massive landslips, act of God or man-made? We get similar things, not quite as bad, but I've seen some major landslips that we've had, not soil erosion, but landslip, where valleys have just poured off the side against property, down the valley, filled the river up with mud, and we've had gullies formed over 50 meters deep by landslip. Now, I think some of these are unnatural, caused by the way the land is being managed, but it's these big storms. We just need to come together where we understand the science. Okay.
Excellent. Thank you, Richard.
Because in the culture is we have these flash floods, rapid response catchments. There's this culture of just we accept it. Big storms, we're going to get flooded. We have this culture, but nothing we can do. Whereas all my experience is that we can do a lot with these big storms. We just need the evidence.
Thanks, Richard. David, and then Tom.
So one I've mentioned that I'd said before is when you've got compaction, essentially you've moved the soil to an alternative stable state, and how you get it out of that is not straightforward. And so understanding what the right sequence of events are to sustain getting the soil out of that. So we can easily go in and we can plow, we can lift, but it doesn't necessarily mean that the soil will maintain its structure. And so it's how you both remediate the initial problem and then go in to maintain and improve good soil structure. I think that's really quite important. And I'm not sure that we fully understand what the right sequence is in which place on which soil types always. So I think there's probably something in that. And it was quite interesting looking at some of the studies from Switzerland where they've been looking at compaction experiments and the sensitivity of different measurements. And one of the things that they had noticed when you look at a soil that's been compacted and then it starts to remediate through time is that you can get a soil which the hydraulic properties improve, but you haven't dealt with the compaction. So it's still fundamentally a compacted soil, but you've put some roots in there, you've had some earthworms come in, and you've altered the macropore structure, which is a small part of the structure, but fundamentally you haven't removed the compaction. And that's an issue because very quickly in an event where you see runoff, what have you, that macropore structure can be filled very, very quickly with runoff. And if your matrix is not contributing, that's important. So I think there's quite a bit of understanding on the sort of fundamental sort of physics, biology interaction that needs to be undertaken as well.
Excellent. Thanks, David. Tom, and then Christina, if you could be brief, please, because we're moving into the last 5 minutes or so.
Yeah, just I think a pitch for more numbers. Policymakers would appreciate some physical quantities to be able to translate into values in terms of economics involved. I think that would also help to put it in the issue into context. You know, how we have the metrics. You know, cubic meters per hectare storage of whatever of water. If we can put some numbers together on those to frame it, put it in the context of what these measures can do, and put a value on it, I think that would make that would really help policymakers.
Excellent, thank you, Tom. Christina?
Yeah, thank you. I wasn't going to mention this, but what you've just been talking about, David, in terms of soil compaction, I can corroborate that 100%. We've got soils we're monitoring that were compacted 2 years ago, and they are still having an impact on the hydrology, even though the macropores at the surface seem to be okay. But I just wanted to pick up on we've had a lot of the two sides of the story there in terms of farmers, and I just wanted to be really positive about some of the farmers we engage with. So, you know, across numerous projects, and if we're about to end, I want us to end with this, which is a quote from one of our farmers, and it was, if we take care of our soils, they will take care of us when the rain comes. And I just wanted to put that back in the mix of the discussion, because there are some farmers out there, they do want to protect the soils. It's their legacy, it's their future generations that they're protecting it for. And those farmers talking to other farmers is the mechanism by which we can start to create this change. And that's the work that we're involved in here at Aberystwyth University. And I just wanted to, finish on a nice positive from the farmers, because they do want to find solutions as well.
Yeah, that's a really important point, Christina. I think we've sort of focused on what do we do if they do things badly, but we want to emphasise that farmers generally want to do the right thing, and how can we help them do that, and how can we reward them for that? Ellie.
Thanks, Pete. Yeah, I just asked a question in the chat about if, you know, inherent soil type is critical and critical to what you should do where. What's the role of maps and guidance? And Alejandro, you came back on the chat talking a little bit about scenarios, which is a critical part of LUNS. So I thought it'd be useful just to have a moment on that, Pete, if that's okay, because LUNS is looking to build future scenarios, and flooding is going to be an important part of that, which we'd like to be able to offer in.
Yeah, anything to contribute on that briefly, panel?
I just put a comment
David?
just put a comment in the chat that I think Host is a really powerful tool for this. I mean, it's quite old now. I think it's probably a couple of decades, but it is an exceptionally powerful systems tool and a really important conceptual framework linking in the soil types into the groundwater, and how that impacts what's coming off the catchment. So I think we should probably be thinking something along those lines of getting it updated and using that to communicate into policy.
So for those of you who don't know, Host is hydrology of soil types, right, David?
Yeah.
Yeah, okay, thank you. Because of extremely poor chairing of this session, we had 3 remaining questions were about the links between policymakers and the private sector. How do we build evidence to support investment in soil-based solutions? And any decision support tools or early warning systems that are available that we can make use of. So in the last 3 minutes, do any of the panel have anything to say on any of those 3 questions? private sector investment, decision support tools, and how can we build investment in soil-based solutions.
We've got an incredibly short wrap up, Pete, so I wouldn't worry too much. We can use
Okay. I don't want to hold people longer than we promised, though.
Perhaps
So we'll go for 5 minutes.
EA's got a rather nice tool, so the alert tool. So I don't know if Richard's still there. Maybe you could say something.
Yeah.
Yes.
Yeah. Yes. We have a public facing alert tool. This is alert means agriculture, land, environment risk tool, where we have and we're upgrading it as we speak. But I can put the link in the chat, or but essentially one of our powerful layers is the LiDAR layer and overland flow pathways, and we can overlay that with soil type, with satellite image, latest cropping data, communities, to slope, really detailed layers now that we're using all the time, and so a lot of it's not open access, but things are changing rapidly as we speak, to make our public facing tool, risk tool, better and more open access. But the stuff that I use internally is really powerful, and LiDAR is a big thing. The other thing, open access stuff, is our risk maps, the flood maps. You can go onto the Gov website and look at the surface water maps and the flooding maps. Really good. And the only thing to add with that about host, for me, the big weak link with host is that host, you have to remember, the hydrology of soil types was developed at the catchment scale. It was developed at the 25-kilometre grid. I know David CH have done work at the 1-kilometre grid, but fundamentally the soils data is just not there, okay, at the field scale and anything less. The national soil map is the 250,000 scale. And so what I see is it's being applied, these big numbers, as standard percentage runoff, cannot be used at the field scale.
Yeah.
And so we just need to revisit the spatial resolution of the soil data.
David, do you want to come in there?
No, he's absolutely right. And that's where it needs updating. Yeah, no doubt about it.
Brilliant. Anything else from any of the other panel members on either decision support tools, on what we can do to enhance investment in soil-based solutions to flooding, and any comments on the links between the private sector and policymakers?
I think there's a real space for making space for water, sorry, pun intended, where the private, so I know there's a lot of focus on regenerative agriculture and this type of thing, but for our soils that generate the natural runoff, we need to put the water somewhere. And so and I'm a real advocate for making space for nature. That would be the last thing I want to end up with. The water has. I'm not talking about all the freely draining soils and all the erosion problems we have. We can work with everyone on that, but I would like to see the private sector investing in nature.
Perfect, thank you, Richard. And I see Alejandro has put a link into a research project, which is, I can't get the chat open.
Yeah, it's the flood and drought research
Right,
infrastructure that's been implemented as a 37 million project that will look at 3 catchments across the UK, but also mobile infrastructure to monitor floods and droughts. Hopefully should help to tackle some of the research questions related to soils and floods.
Brilliant. Thanks very much. You've been a fantastic panel thanks for this. Thanks for speaking to us, and thank you for the brilliant discussion that we've had. I meant to know some of this stuff, but I've learned a huge amount this afternoon, so I'm really glad that I attended. Just attending rather than sharing, that would have been good enough. So thanks very much. I'll hand over to Ellie to close the meeting.
Yeah, thanks very much, Pete. Yes, a huge thank you to all our panel. I think, yeah, as Pete says, we've all learnt a huge amount. Yeah, it's been a really rich discussion, and I feel like one of the critical takeaways is that we need more join up in this area, for which, of course, there is ample opportunity. And from our perspective, Pete, you and I will go away and kind of re-listen, look at the workshop sort of takeaways, and think about what that might look like. Yeah, so we'll summarize the whole of the discussion in a short report, which will be available on the website. Panel speakers will come back to you if that's okay, just for sort of sign off on those things, and to make sure that if you've got any final things to add in there. We are really interested in this whole theme of soil and water, as you can imagine, be a big part of LUNS, looking at pathways and scenarios, etc. So to kind of, how does soil fit into a future more net zero focused land use? So we propose to do a couple of kind of follow-ons from this, which we'll be looking at, for example, drought, and what kind of inherent soil properties are important for thinking about soils around resilience, and also what role the private sector, that might be water companies, or we've got this huge growth agenda going on, there's going to be lots of building happening. So how do we need to be thinking about soils and water in those different contexts as well? So once again, just a huge thank you to everybody here. Look out for the report coming up.
Thanks very much, everyone. Bye.
Thank you.
Bye.